Wrong screen to share, stop presenting. Share this screen here. Okay, all right, here we are, guys. Okay, so we're looking at your world map, or not world map, your United States map. You did a pretty good job here. Like I said, I would have went ahead and created state polylines and put them together. One thing you can do is you use the bpoly command, bpoly. Say you wanted to create it for Texas. You're going to pop out the bpoly command, which is boundary creation, and you can actually pick a point. It'll do island detection. I'm going to turn that part off, and I'm going to just pick a point. All right, so I'll pick a point, pick it inside here. I picked a damn piece of text. Pick it inside here. Says my point must be located within an area completely enclosed by one or more objects. So that means what happens is you have kind of open polylines here that don't actually kind of connect. So you might have some spots down here that don't quite connect, or they might. I'm going to zoom out a little bit here. You have some that might not connect in here. Like down here, you got some circles. Oh, it's telling me these are the circles where it's actually kind of showing where some issues are. Like they don't have connections down here or something. Maybe it's, God bless. I'm zooming way in here. Maybe not. I don't know. Boom, boom. It's open. So if we look here, it's kind of hard to see the differences here. But you see, oh, actually one's a P line, one's the other one. So if you take this one and you move it to the endpoint of this one here, then that actually helps close that point there. I'm going to zoom out a little bit, and we can look at this spot over here as well. You can see here, we're going to move it here. And all I'm going to do is I'm going to highlight this. You can see a little bit of a jagged edge there. It's hard. You'd have to zoom in really close, apparently, and then really close. And sometimes it's so minute you can't really see it. So I can pull it up over here, and then I can actually just pop it, hit here, and then snag it to the endpoint of this right here. All right, and that should take care of that. Let's see if there's any others that are issues. Boom, 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 boom. And then you kind of get over here, you have another potential spot here, but it doesn't seem to complain because I think you brought that to the intersection. So I'm going to erase the Texas right now, and I'm going to do a bpoly and see if that kind of fixed it. And I'm going to pick a point, island detection, boom, pick, and there. Now I have a polyline there. Okay, so I'm good. I accept that, and now I have a polyline. Move last, and there's my state of Texas right there, and you're good to go. So you can use the bpoly command to create a polyline that kind of is the shape of the area that you're actually within. So if you use a lot of lines to get together or something like that, you can use the bpoly command to do that. It's almost like Hatch, because Hatch uses the same thing and checks that boundary for it as well. So that's why bpoly comes across there. In fact, what Hatch does, it basically creates a boundary entity that actually kind of encompasses that, and it's just kind of all done in the background. They really don't know about it. Okay. So good job. Stay on top of that, and remember the bpoly command. Something that Brandon is doing while he's here, I've decided to go ahead and make him go ahead and get AutoCAD certification, primarily because it just will help him show that he actually knows his stuff. And so for the most part, Brandon's been working through that. He's been studying that and doing that. Just using some LinkedIn classes to kind of go through that material. It covers the material, and for the most part, everything I've been teaching you all is straight on with that stuff. So you actually see that. Of course, I teach you the command line options and kind of show you that there's plenty of ways to actually work with things, and that way you're not kind of handicapped with it. It's kind of drove Brandon crazy because he's like, he's keep picking from the menu. So it's all right. And so I told him, when you watch a video of someone actually doing something in CAD and you're trying, and they pick a button, okay, if I type in ribbon, and I turn on the ribbon, and I pick this command up here, I just pick that. Now, what command did that run? Okay, you're like, I don't know what command that ran. It just says pick text, and you're typing, boom, you got your text, and then boom, kind of go here. You're like, oh, what did that do? Okay, if you hit F2, you can see here, I turn on the ribbon. You don't actually see what command actually run, but if I hit the space bar to run the same command again, okay, you can now look at what it's running. It can't ran the command mtext, and so therefore you actually understand what command you'd actually run to type it at the keyboard. So if I do that, I type in mtext, and I type it manually, I get the same exact command as if I was up there and I pick the menu or pick the ribbon bar. So if any of these that you're actually curious about, you want to do something with, Like if you want to click on something, let's do something, trim, rotate, fillet, because you might not know what this is here. You see that says explode, okay? And that tells you what the explode command is. But if you see someone in a video or something like that, and they're clicking on things, you can actually click the same spot and then find out what command they actually were running. Okay. So that'll be helpful in that aspect of it. I'm going to type in ribbon close. You get rid of the ribbon because I just don't care for the ribbon, just don't use it. There are some benefits to the ribbon quite a bit if you're using it, but I'm trying to teach you guys not to be dependent on any particular interface, and that way you could actually utilize the keyboard and be a lot more efficient on anything you need to do. All right, something that Brandon was doing today, he was drawing, let me close some of this stuff out. I had him drawing a PID detail, all right? And he did a good job of sketching in the items and everything else. But it's very important to utilize the skills I've talked to you guys about, which number one, snap. If you're drawing a particular type of drawing and there's a standard precedence already set up, okay, you want to kind of look that precedence up. So if someone brings you a PID and it has some instrument bubbles on it, has some valves on it or something like that, and you're like, I don't know what the hell those are, and you kind of go from here to there, there's lots of different things that you can do to get what you want. Here's what I'm going to do. I'm going to pause for just a second, and I'm going to grab the file. I keep that print. Let's see. There it is right there. Copy this real quick. Give me a second to get this over here so we can look at it on screen. Getting it together, no big deal. Just hold on. We'll be there in just a second. And I'm going to crop this before I put it on the deal. So we're going to edit here. Nope. Edit. Crop pages. We're just going to look at this part here. And here, okay. All right. So now we can see what we're trying to draw here. Okay. So you look at this. This is a P90 detail. All right. These are instrument bubbles. All right. When I handed this to Brandon really didn't know what these were, but he drew it and put it together and everything else. There's a few things you have in here. Now, when you look at this, I'm going to go to the comment mode here and kind of highlight some things. If I go here, I'm going to put this in opacity a little bit here. I'm going to kind of go with blue's not bad. We'll go with that. Okay. And we'll go here. All right. So this is a line. This is a line. This is a line. Okay. Line, line, lines, 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 and lines. And then there's these primary lines here. You notice those are a little thicker. These are meant to stand out for a reason. Okay. Let me zoom in a little bit more so you can kind of see that. Oops. The pan does not work on Adobe. All right. So anyway, and these up here, I'm going to go to a different color here. And I'm going to stop this, pick a different color, and we'll go with orange here. Oh, that's not what I wanted to do. Go back to blue, pick this, pick this again, pick this again, and now again, and now we'll go to orange. Now these are symbols. When you have symbols, they're going to be a standard size, okay? And you want to work with these standard sizes, so you want to make them a block, all right? That's the first thing Brandon did is he made these in blocks. He made them attributed blocks as well, and you kind of see what they are. So you have all these. You essentially have 1, 2, 3 different blocks that all come together here. The circle in the center, as you can see, is kind of a commonality between them. You have the diamonds in here, but those are a little bit different. But for the most part, these are all the same thing. These are instrument tags or instrument bubbles. Okay, they're called bubbles because primarily they're this particular thing right here. This means it's a field device. All right, this means this is actually in the control panel. This is also in the control panel as well. This is a different type of signal, and this is a different type of signal in actually a different panel as well. All right, so you can see the UCP here stands for unit control panel. And you might see things for PLC, you might see station control panel, you might see Rio, you might see all kinds of different things to identify where that panel is located for where this instrument or this device actually is. This is the solenoid. Here is an electrical signal that comes to this solenoid and tells it to open or shut. Okay. When it closes, okay, it lets the air come through here. When it releases, the instrument air will come in here and flow where it needs to be. So this is a three-way valve, essentially, and it's either letting hydraulic flow this way, or it's going to go straight across. So it depends on how this actually comes up. There's more in-depth discussion to go into that, but I'm just trying to get past it quickly. And then down here, you have, this is a symbol here, and this is a symbol here. This is a valve. This is a solenoid valve. This is a three-way. This is a two-way. It basically opens. It's either open or shut, go in this direction or this direction. This one's either open and shut, go in this direction or this direction. So to build this, you need to have some layers that have these line types in it. Okay, and you can create line types that actually have letters or characters embedded in them. You can also have line types that have dash or crossing lines like this here. And you can also have lines that are a little thicker. We've worked with those with using P lines, but you can also use a color table on your plot style to actually control and make this pin width here thicker. We've gotten into a little bit of plotting before, but we're going to kind of stay away from that for right now. We're going to talk about these symbols. So what you want to do is figure out how you're going to develop your symbols, because if you're drawing more of these, it makes more sense to actually set these up correctly and properly. Now, for this one particular detail here, we have 1, 2, 3, looks like 3 blocks there, 4, and 5 blocks to set up. We have 3 instrument bubbles and 2 valve symbols we need to create. All right, so you can create those and get those done. So you want to find out what sizes do they need to be? What kind of snap do I want to be on? How do I want to draw this to make it more efficient and everything else? If you just pop in here and start sketching, you're going to end up using your typing in O snaps, endpoint, intersection, midpoint. You're going to be bouncing all over the place and everything else. But if you set up your snap, you can draw these things pretty quickly. So I'm going to move this out of the way, and we'll kind of draw some of this. Okay, I happen to know that industry standard is going to be like a 1/2 inch bubble. Okay, so I'm just going to type that in. I'm going to go 0, 0, 0, boom, and I'm going to say radius, okay, of 0.25. Boom, zoom extents. That's a 1/2 inch bubble. All right. So now I need to add some attributes in here, ATP, DEF, and I'm going to set my tag. I happen to already know this, that those instrument bubbles have an instrument type at the top and a tag at the bottom. So I'm going to say INS type. All right, just say INS type, all upperlays, because our attribute tags are always capitalized, because it ignores case. If you type it in lowercase, it's going to be capitalized. It doesn't really matter what you do there. So here you can actually put in the differences. You can use upper and lowercase here, instrument type. And by default, you can put something in there. I'm just going to put PT for default. All right. Now, I don't want it to be left. I want it to say it's a circle. So obviously it needs to be something like a center justification. You can also use a middle justification or a middle center justification. I'm going to go over middle center justification. And I'm just going to go ahead and pick a spot, and I'm going to lock the position because I don't want it to be moved. All right. Specify a point on screen. It's not going to be invisible. It's not going to be constant. I don't really care to verify it. Preset, no big deal. And multiple lines, no. So I'm good here. Style currently is standard. I'm going to go to that for right now. But I want my text height to be something particular. When you're dealing with standard text on a drawing, 0.125 is a really good standard text height. Okay. 0.09375 is another very common one. 0.0625 is getting really, really small. But 0.125 is a very common one because it's easily read on drawings, even if they're scaled down by half sheet. So if you print down a D-size drawing to an 11 by 17 sheet, you're going to get a really good print, because then it'll be 0.0625 in height. So I'm going to say 0.125 here, and rotation is going to be 0. I'm going to pick OK. And I'm just going to set the center of the circle for right now. Boom. So it's there. Now I know I want to move this up a little bit. I know this is 0.125. This is a half-inch circle, so I have to actually move this up another 0.125. I'm going to turn on ortho, 0.125. Boom, and now I'm right there where I need to be. Now I'm going to copy this from here down 1/4 inch, 0.25. Boom, and now I look at this and I'm like, okay, I could probably close this gap a little bit so I have a little more room, because you see how quickly the circle, the arcs start to encroach on your line, on your text. So I'm going to move this down 0.0625 and try that 0.0625. And I'm going to move this up 0.0625. And then you're thinking, oh, well, it's a little bit too close. So now you're thinking, okay, maybe I need to bump it out 0.03125, half of 0.0625. So I'm going to do it again. I'll move this here, 0.03125. Boom. And I'll move this down 0.03125. All right, so that works pretty good. Now, something that would make life easier on me if my snap was actually set up. So I was taking snap. I take my snap, it's at ½ inch. If I turn on snap right now, it's going to be popping half of the bubble. So I want to actually set that to 0.0625 is a pretty good snap height. So now here I am. I've created my bubble, but I've created one type here, but I need to change this attribute definition here to be a little something more consistent. I'm going to move this over here. I double clicked on it to pop up the attribute definition dialog box. And this one's going to be my tag. So I'm just going to simply go INS and then tag. Change that over there, and I'll type in tag. I'm going to give it a default of 1001. Just for, something to show up as a default. All right, so now I've created my block, my instrument block. So if I dot block this, and again, you want to pick a good center point or insertion point. Center is a really good spot here. Since I have my snap on, it's automatically right there. So I pick right there to the center of that because it's on snap. I drew it on snap to begin with because I placed it at 0,0,0. It's actually already at the default insertion point for the block. So I'm going to just pick there, and I'm going to select my objects. Now I'm going to select the objects. I'm going to select the circle, then I'm going to select type and tag because that's the order I want them to actually be prompted in. So I'm going to just type and tag, pick that, and here I am. I know I've gone through this material before, but I just want to make sure you guys get this and kind of just make it part of your brain the way you think. Okay, pick OK, and then, oh, I did not create a name. We're going to call this inst bubble. Okay, you want a block name that makes sense, and you want an insertion point that makes sense, and you want everything to be good. Another thing that I want you to point out here is I actually created this on the 0 layer. And what layer is it on right now? It's on the 0 layer. So now if I create a layer and I call it instrument, and I set that to magenta. Okay, something that kind of stands out. Pick OK. And now, is it going to change my block? No, it's not, because that block is on 0 layer. So if I set that to magenta, the instrument layer, it automatically changes colors. Okay, so now let's do this a little bit differently. I'm going to copy this, and I'm going to put this over here, 1 inch over here, and I'm going to explode this, and we're going to create a different block, and I'm going to move all this. I'm going to move all this to the instrument layer. All right, got that. My bad. Move. Hit the wrong keys. My bad. Can't operate keyboard. Okay, so highlight all this. I'm going to put this on the instrument label because I want it to be on the instrument layer. So now I'm going to block this and pick my point. Again, I'm going to pick right in the center of this circle. I don't have to use those snaps because I'm on snap. I don't have to worry about that. So I just pick that center right there. I'm going to select my objects. I'll pick here, here, and here, and I'm done. All right. So I'm going to convert that to block. Oh, I need to give it a name again. I'm going to use the same thing, but I'm going to call this layered. Just for so we understand what it is. Pick OK. Select objects. Yes. Pick, and pick. Boom. And pick OK. And now it's created that. And I'll pick OK. Now we have 2 blocks. They're both on that layer there. So now I have another layer that I want to create, and it's going to be special instruments. Okay, but I want those to show up as cyan. All right. And so now I'm just going to, this one's my special one. I'm going to put that on special. All right. But notice it did not change colors because the entities inside this block were created on the instrument layer. So everything inside this block is on the instrument layer. The block itself is inserted on special instrument layer. So what you want to do to get that kind of functionality is make sure your blocks are created on the 0 layer. So if I bring this up here, 1 this direction, and I change this one to special, boom, it operates as expected and does exactly what I wanted to do. So again, create your blocks with everything on 0 layer and color set to by layer. Everything's set to by layer, by layer, by layer, so you have that control at the layer level. If you get into the habit of deforming your blocks and deforming your entities and everything else based on individual property settings, you will lose control of your drawing. And when you go to edit things, it'll make life a little bit more difficult for you. All right, we're going to delete that. We don't really want that block. We're good. All right, now talking about line types. All right, so I'm not going to get into every block. I'm just going to kind of go from here. We're going to call this a PI now and pretend it's actually got that box around it or something like that and pick that there. And now I'm going to draw a line from here. Again, I'm on snap, so I pick here and I pick here. I don't have to type in my O snaps or anything like that. Now I pick on this. I'm going to create a layer. Now we're going to call this layer pneumatic, if I can spell. Hey, I think I did it. Okay, now we need to load a line type. I'm going to load. I'm going to scroll down through here and see if I can find a pneumatic line type. 9 times out of 10, there is not a pneumatic line type. By default, you have to typically find a specialized line type. So let me see if I can find one. Cancel. Hold on one second. And where you want to look is in LIN files. I happen to have a ton of LIN files, so I'm going to go find one and use it. So give me just a second to find one that has a pneumatic line type in it. Boom, I'm here. Star dot LIN. It's not going to search for me, is it? Yeah, second. Okay. All right. Cam. Come on. Really? You suck. Okay. Oh, now it's gonna give me something, maybe. Okay, no. I know I just made some line files the other day. It always amuses me when the search function fails to work. Okay. Type. Get line file. Let me see what's in this one. Sonic. Yeah, here we go. Well, here's some that have some things in it. I'll go ahead and load from this file here. So I'm going to browse. I'm going to hit load. I'm going to browse. I'm going to hit the browse. The way I find the different line files, I hit file here, and I'm going to go to a different folder. I'm going to go to my Dropbox location. I'm going to go to my development folder, which I think that's where it's at. There's an ACAD line file in here. And this one has a lot of different lines in it. Bad definition at line 146. Okay, who cares? 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 Goodness, this line file sucks apparently, but I can get down here and possibly find a few things that work here. And I still don't see a hydraulic or pneumatic line type in here. Let's pick something that has something different in it. We'll go with the fence line with the circle. Okay, I'm going to pick OK, and I'm going to set my line type to this. It looks more like a software line type. It's not a pneumatic line type, but any way, means, or shape, or form. But at least you can see the variations there. All right, so if I set this now to that layer, pneumatic, now you're like, okay, it doesn't show up. Okay, so let's stretch this out a little bit, because depending on the size of that line type setting, it might be different. See, that's actually a rather large line type. It's meant for more of a fence line. And so it kind of shows those little circles, dots like that. You can control the LT scale of this drawing file. We'll type in LT scale and set it to 0.5, but that's going to affect everything in your drawing. So set it 0.5, it does scale those bubbles down. The line type definition files look similar to this right here. Okay, you can come in here at any point in time and create your own line types. It does take a little bit of understanding of what you're doing here, but we're not going to get into that right now. I'm just letting you know you can create custom line types coming into a text file and editing them slowly and methodically. Otherwise, you'll get all those errors that we just saw just a few minutes ago. Now, some things like this use an L-type SHP file. Okay, so you kind of get that going in there. And what we're going to do is we're going to actually draw another line type in here as well. I'm going to copy this one over here. I'm going to create another layer. And we're just going to make another line type layer that has the line type that has text in it, other. And we're going to pick another line type. I'm going to pick, oh, not that, not color, line type. My bad. Load, and we're going to scroll down through here again. And you see hot water supply, you see gas. Okay, so I'm going to use the gas line here as well, because you just so you can see what the style looks like when you actually have text inside your line. Okay, so we click on gas, pick OK. And now anything that's on that layer will show up with the GAS written into it. So I'm going to go ahead and do that, pick other. And now if you zoom in on here, you can kind of see how it says gas in here. Now, again, the orientation is going to be based on the direction you drew the line. So if I draw the line from here to here or from here to here, these will have two different orientations. So if I change these to the same layer, I'm using a list routine called CL, change layer, and I'm just pick the ones I want to change, and then I pick where the layer I want to go. See how gas is going this direction, gas is going this direction. Make sure, most people will not beat you up on that, but I mean, if you're going to be kind of like anal retentive on it, you might want to make sure your gas is readable at either the print in this direction or across this direction. You typically don't want your text rotating past 90 degrees or past 180 or anything like that. You want them to actually be between 0 and 90 degrees. So this would be at 90 degrees. This would be at 270 degrees, which is incorrect. Because when you're reading text on a print, you want it to be in a particular fashion. So in other words, if we were looking at this bubble, okay, copy this down to here, you can rotate this bubble this way, but you would not want to rotate this bubble this way or this way, because the reading, you either rotate your print, if you have a print closed and your text reads across the text. Right, boom, boom. This is text. I can't type. That's okay. We've established that. Okay. You would typically, this is usually your stick file end over here. Okay. I'm going to draw another line over here. So you kind of understand this is kind of your stick end. Okay. You will lay this on a table. Say this is your table here. And you'll read it this way. But you're not going to bring the stick towards you. You're not going to rotate this way. Okay. You're going to rotate it down towards yourself. Okay. So you want the text to be readable towards you. So RO, let me undo that. Okay. You will typically rotate the plan, because this is a stick file. This is the side that everything is bound upon. You don't want to rotate that towards yourself because that's a heavy end and it'll drop down towards you and drop on your feet. So you typically rotate it down like this. Okay. So if we undo that and we put text, I'm going to copy this text. I'm going to put a couple of different pieces of text here so you can see different rotations. If I rotate this and we change that rotation to 90, we change this rotation here to 180. We change this rotation here to 270. Boom. All right, now move. You got these pieces here. Boom. Here. All right. And actually, we'll just do this. We'll put it on the end, 90. And we'll put it on the end of here, 270. All right. Now, if you rotate this drawing again towards you this way, okay, you're flipping the sheets towards the top. You can read this just fine. You can't read this very well. This is upside down. I mean, some people like myself can read upside down just fine. But you want it to be consistent. And so you want it to read in the correct formats. This is 180 degrees. So this is actually bass backwards. You're reading from bottom up. And typically you want to read from top down, because that's how we actually read our books. We read top down and left to right. And so that's kind of how this is correct and this is correct. This is 0 and this is 90. So anything in between those will typically show up and be easily read. And your goal as a drafter is to make sure that the people reading your drawings can read it easily and efficiently. You don't want to have text going 15 different directions. Now, again, on a line type, that is being kind of anal. And you don't have to beat yourself up on that because it presents its point. It's easily read once and it kind of goes. So that's how you actually control those line types. And that's how you kind of establish when you're looking at something like this, how you're going to build. If I can get it over there to the screen, how you're going to build these entities. This can be controlled by a layer, These are your blocks here, and you'd actually develop those blocks. Now we talked about this bubble being here would be a 1/2 inch bubble. Okay. This text inside would be 0.125, which is 1/8 inch text. If that's an 8, if you can see an 8 down there. Okay. And this here is a solenoid valve, okay, or a valve. 9 times out of 10, you will have something like this, and it's this distance between here and here is typically a 1/4 inch. Okay, so let's draw that and see how that looks. Okay, and see how that actually scales up. I could be wrong. It's been a long time since I did valve blocks. Okay, so draw a P line, boom, and we come up 0.25, boom, and then we come over here 0.375. But oops, if you type, yeah, and then come down there and then close. Boom. All right, so now I can take this and I can move this over here, and I can take this up to here, and I can take this down over to F8 over to here. Okay, so now here's our valve. Take this and move it into the line somewhere. So we put it right here. You kind of see how that would actually end up breaking out. Then you actually break this from here to here. Okay, trim. You click the one entity, you pick here, and you're easily click to trim those things. Now, block sizes and things like that depends on the software you're using, everything you're using, but typically the instrument level is going to be very standard. Valves, this may be a little bit big for a valve. It might not be quarter inch, might be 3/16 of an inch, and then it'd actually be a little bit smaller valve, and especially where you're going and things like that. You have different valve sizes on a drawing as well. Okay. Sometimes the solenoid valves shown a little bit smaller. Sometimes the main valves are shown a little bit bigger. But 9 times out of 10 with a PID or something like this is your main line. It's a main process line, so it's going to show up nice and thick. These are secondary because this is a hydraulic line that actually kind of closes this or opens this valve. Depends on what the function of it is. This one's fail close. And so what happens is you have these lines that actually kind of have influence over these elements, and that's what these lines are for. So they're going to show up as secondary. They're not going to plot as thick as the main line coming across this. And similarly over here, let's go over here. You can see how these are all kind of done here. Not a big fan of angling your lines in on a PID. I can see why somebody did it, but I'm usually not a fan. Typically, you'd come up here, boom, across here, and come up here, across here, boom. Okay. All right. I think we'll stop with the PIDs, kind of minimize that a little bit, and kind of pick up on something else. All right. Now let's talk about some fun stuff. Recently, I've been working on a clock project, and something you can kind of do is you can kind of draw your gears and everything else. Brandon kind of went through a little exercise. I handed him a gear and said to go ahead and draw this up. And what's nice about a gear is you look at it from the plan view, and you can see pretty easily how easy it is to draw. All right, you just kind of draw it out. You take your measurements and you construct it, and you draw the gear. Okay, and then from that point, we just basically extruded it, and then subtracted whatever we wanted to make the holes and make the cuts on it. And then from there, we took it to an STL file, and then sliced it in the Prusa slicer, and then dropped that on the little mini Prusa and printed it out. How's that, Brandon? Pretty cool. Yeah. And so that's definitely something we want to get you guys to understand that, CAD is a lot more than just 2D drawings. It's definitely can be 3D modeling. You can actually start printing things. You can actually start drawing things, constructing things, and everything else. There's a ton of things you can do with it. Don't hesitate to look at something and just draw it. Okay. So if you grab something, you want to draw something or something like that, like I've got a remote control sitting in front of me. That would be so easy to draw. Okay. And then model it. I know you can't see it, but just imagine a remote control in your hand. Pick more of a square one or a rectangular one, not one of the ones that has the fancy curves and all that stuff on it. It might be a little more tedious to model, but it's still something you definitely do. Your phone is definitely an easy object to model. We did one of those at one point in time. You can model just about anything around you through shapes. You can subtract, union, and you could slice. There's all kinds of different ways you can actually do things to get to the points you want to be at. And so I don't want you guys to think in limiting terms. You can do anything you want to. So what I had to do here is I had a motor that had a much bigger shaft going through it. And so what I needed to do is I need to make my gear over, but with a smaller, tighter shaft with a small little D shaft in it. So I made that, put that in my clock. That thing works great. Then I also had my motor mount that I had to create. I had a little small motor, and we're talking tiny. The thing is like 1 inch by maybe 3/8 of an inch, and then it's just a little tiny thing. And so I had to have something to hold it, and then also let the end of it stick out. And then I had to find something to be able to screw it down to the surface that I needed to go to. So I made this up, and then I printed it, and everything was good. What I typically do when I'm doing my model is I will start with my model in the center, and when I get to particular points, or I'm constructing it, I'll make copies of items in different locations. Like here, I was testing this up here. I made a copy of the base, and then I just printed it out real quick to make sure I had the alignment correctly, because I didn't have anything really well to test the angle of the circle that was actually on the base. It was actually 5 degrees off center. So I went ahead and rotated it out 5 degrees, printed that out, tested it, and worked like a champ. But again, as I'm doing things, I'll actually just create copies and locals. Like this one here doesn't have the cutout of for the motor to go in. And so I create little spots for myself to actually cut back and redo something. Because if you extrude, once you extrude an entity, that entity is gone. So then you just have the solid. So you don't have what made that solid extruded. So I usually keep copies of them so that it makes life a little easier for me to actually go back and say, oh, I just erased that, remake it, and then I can cut it again and then get it to where I need to be. So that's just a little trick that I use. It's not anything fancy or anything like that, but definitely useful. All right, here's something else. My wife has a infrared panel that sits in our bedroom, and she sits in front of that thing for it. It's a therapy device, and it gives you infrared light across your body and everything else, and it just helps your body regenerate. So my wife uses this thing, but it has an annoying LED light on the side of it. And she's like, and we usually just throw a t-shirt over the top of it. So I told her, I said, I can make a little cover or something and go down on it. But the cover is going to be like 8.5 inches by 3.5 inches tall, deep, and then like 2 3/4 inches thick. My process slicer will only print up to 7 inches. So what it is, I kind of modeled it up, and then I made it to where it will actually join together with just these kind of little things to hook together. So if you actually take these pieces from here, you go from center of, then once it's printed, you take them and you just put them together, and it makes life. Then it just looks like a nice solid piece and goes on top of it. When you are doing things like this, you definitely want to have a gap in there. Notice there's a gap. Mine actually ended up being a little bit too big. Depends on the accuracy or the tightness of what you're printing. I have mine printing at a decent detail level. So it's not as snug as I want it to be. So if I'd have made this a little bit thicker, they would have actually kind of compressed together and stayed a lot better. And there's lots of different ways you can do connections. You can do little clips. You can do. I just threw this together really quickly, printed this out. This happened to be a 24-hour print, but it works just fine. It's 1/4 inch thick all the way around, and the light actually still does kind of bleed through because it's a really bright light. So you can see why she didn't want to have that on there. But I cut it in 2 pieces so it would actually fit on my board, and I could print it all at one time. So it just printed 2 pieces, and then I was able to pop it off and then use those just fine. Brandon did the same process. He created a gear, threw it down on there, and we printed it, and it was great. It was rather large, though. One thing happened was when he was making his measurements, when you're taking a caliper and you're taking the measurements, you like look at that, and you're like, boom, you type circle, you draw your circle, and then you provide the values that you got off the caliper.
Very important.
And the problem is it's prompting you for a radius, and you're giving it a diameter. So you're actually making it 2 times as large as it needed to be. Because it's funny, because it popped it on there, started printing. I looked at it like, whoa, that thing is huge. What happened? And then it's like, oh, it's 2 times as big as it needs to be. It's like, it's a very common mistake. It's definitely something we all do. Like, okay, I want a 1/2 inch bubble. And so you type in 1/2 inch, you forget to actually divide it by 2 and give the radius. But keep in mind, when you are drawing circles, you can always give it a diameter. So if you type in circle,
Started doing that.
when you pick a spot, you can actually hit D for diameter, and then you can give it a diameter. So if your diameter is something weird, 0.12, and boom, and you hit that, then you know that is the diameter. So that now you click on this circle, boom, you can see the 0.1926, and then you can see the radius is half of that. So it automatically takes care of that for you. You don't have to worry about that. So you can actually just give it the D for diameter, and you're good to go. But it's definitely something to keep in mind, especially if you're printing, because you'll throw it on printer. You're like, just take a nice 24-hour print. And you're like, oh my God, it's the wrong size. Something else actually comes up while you're doing your 3D prints is most printers, 3D printers typically, and slicers typically work off of millimeters and not inches. I drew all this in inches. So when I bring it over into the slicer, the Prusa slicer, I had to actually scale it up in the slicer by 2,540%. Okay, because there are 25.4 millimeters in an inch. Okay, so that's kind of how you end up doing that. All right, so that kind of takes care of that. That talks a little bit about that. We've talked about your world map a little bit. We talked about drawing here. Um, layer management. Brandon, what are some of the things that they kind of covered in the class for you? Do you have that up or do you want me to bring it up over here? Okay. Actually, here, I'll just read, I'll bring this over here.
Layer state.
Okay. All right. Now, let's talk about some of the things they want you to try and learn primarily in the exam. To see learning offerings overview. You don't have to have all the hours they they talk about required skill sets to complete successful ACP. You need approximately 1,200 hours of real world AutoCAD software experience and a general understanding of the following topics: drawing and organization, drawing and organizing objects. Okay, we talked about layers. Okay, we talked about blocks. We've talked about all the types of objects you can create. We talked about inputting those dimensions and everything else. You've covered all that. Drawing with accuracy. We talked about snap. We talked about OSNAP. We talked about using your units, using decimal, architectural, and understanding where the rounding issues could be on those things. And so you've learned about that. We've talked about scale factors. We've talked about quite a few things there to help you with that type of stuff. Advanced editing functions. Okay. Some of the things that actually Brandon was discovering with this is the guys talked about quick select, and quick select is really useful. Select by or select, similar. So some of those things would be like here. If you click on, if you have problem solve box, you have quick select right up over here. You can also at any point type in Q select. Okay. What's nice about Q select is it allows you to isolate things rather quickly. So if I'm looking for items, anything, multiple means I can select multiple objects, but I'm looking for them to be on a particular layer. So I want everything that's on the other layer, boom, and I pick OK, it highlights all those things and I can move those or delete them or get rid of them. So I'm just moving those things there. Now, if I want to find something else, say I actually want to look at for all these blocks like this. If I know I want all these blocks, I can highlight this. I can go through Q select like so, and I can say block reference. It's already selected block reference because I had that selected already. So I can come down here and go to name, boom, and I can say instrument bubble, pick OK, and it's going to select all the blocks that have the instrument bubble. You missed that one, or did I? That's the wrong one. Huh? That shouldn't be a matter. Okay, so let me check that again. All right. Oh, well, because I had it selected already, so that's my bad. Q select. I'm going to do that again. I'm going to go block reference, and I'm going to stick the name of the block. Click name. Scroll down here. Instrument bubble. Pick OK. It's going to highlight all the blocks that are in by that block. But notice that it selected the one on the other layer or the isolated or special layer as well. Maybe I don't want to work with that one, so I can bring up Q select again while I have those selected, and I can actually do this one, and I can say, make sure that layer, okay, it equals other or something similar to that effect. I can say other, which I think that's what we put it on. Was it other? No, it wasn't other. It was special or something like that, right? Layer is special instrument. All right. And I can actually say exclude. So now I pick this, pick OK, and now that one's no longer part of the selection set. So if I had 37 of those out there, it would actually remove all those for me and I don't have to worry about that. So there's lots of different ways to do that. That gives you the Q select there. So you can take those now and move those, do something with them or erase them or whatever you'd like to do with them. You can also, if you highlight these and say you want all of those to no longer be PTs, you want them to be PITs. Okay, pick OK. And now suddenly they're all PITs. All right, so you're good there. Now, another thing you can do is you can highlight one, right click over it, and you can say select similar. This is going to select everything similar to that one. Now, this one by default is going to look as much isolation as it can. It's saying this is a block and it's on this layer, and that's what it's selecting similar by. It's not selecting this one because it's on a different layer. So it's not going to do that. So that's why that kind of gives you a little bit of benefit there. So you have to understand select similar is going to already kind of look at what you've done. It didn't worry about rotation because you can see this block is rotated a different way than this block. It didn't worry about that, but it did look at the layer and the block name and say, this is what I want to do. And so if you had some at different scales, it would probably select all those at the same scale. So you have a lot of some quirks that will actually take place with select similar, but 9 times out of 10 it's going to work just fine for you. Same thing works for 1 second. So if you're selecting lines, all right, these lines here, if I do this and I right click select similar, it's going to select all the lines that kind of match that property layer. All right. And so select similar is nice for that. Let's go back to our AutoCAD stuff. So that's kind of the advanced editing functions. You'll use P-edit. You've done that as well. You've learned how to use array. You've learned how to use trim. You've learned how to use extend. You've learned how to use fillet. You've learned how to use camper. Campers 9 times out of 10 you're not going to use. Advanced layouts. Oh, also one of the other drawing and organizing objects thing is they talked about regions. Regions are essentially like polylines, closed polylines, but they have some special properties that you can actually isolate and build off of, like center of gravity and some other little things like that, or balance points and such. I don't use regions, so you can use them, but just understand that they're out there. Advanced layouts, printing, and alternative outputs. Now, we've talked about this a little bit. This is where we're talking about model space, paper space, and using like XREFs and things like that. Now, I talk about alternative outputs. That's when we're actually, instead of going to a printer, we're actually outputting to like a PDF file. You can also go to a DWF file. You can also do, like we were talking about, outputting to an STL file for, you can actually do that print. And we were just discussing those things. Annotation techniques. We have not got into this a whole lot yet. Okay, but you have leaders, you have multi-leaders, you have dimensioning, you have a lot of different things to use for annotation. We have talked about text quite a bit, and we've talked about using scale factors to adjust your text. We've talked about attributes. That's definitely annotation as well. And we talked about adding attributes into your blocks. So you've got all that knowledge in there as well. And then reusable content. That is exactly what we were just talking about. Okay, blocks. You get those blocks, you generate those blocks, you can have you get content you can actually copy from one drawing to another or insert from a file, drop that in there. You're going to build faster. You're going to have templates make it work for you and everything else. Drawing management, understanding how to name your files, how to work with your files, understanding where you're locating your files. And you can get into some of the, I don't know if they're going to get into like sheet sets and stuff like that for you, but sheet sets is a useful tool. 9 times out of 10, it's not going to be used anywhere. There are some really beneficial things to it. I typically use a database driven system to do that kind of stuff for myself instead of Sheet Manager, but there is a lot of different management tools built into AutoCAD as well. So if you're thinking about certification, if you already have a job like you do, Cody, it's probably not going to be that beneficial for you. But it's not a bad thing to have under your tool belt just because you're still so early in it. Same thing for Brandon. He's here with me, so I'm going to help train him to where he actually has all that knowledge so he can actually go ahead and get that certification, because he's going to try and either get a job, hopefully working with me, or doing something on his own out there in Alabama. So we'll get something going from there. So I think that's about all I'm going to cover for tonight. And well, I guess you can talk about this. It's a 120-minute exam time. Cost, it looks like it's $200. It's 45 to 60 questions. Exam and proctor available in English. Essentially, I don't know if they do it online or if you actually have to go to a testing center. I'm not sure. We'll have to look that part up. Certification. What's that?
Looks like it was online.
Online. Okay, so online testing center. Retesting is required to renew certification. Honestly, not dissing Autodesk on this, but once you have your job, you've already had 3 years of experience, you're qualified on CAD. You don't have to really worry about that. And AutoCAD does come up with a lot of new features, and so they're going to have new features and things like that built in there for you. So overall, you're going to be in good shape, and you would not need to necessarily recertify. And people are going to look at you. You were certified at one point in time. You know AutoCAD, and so I don't see a whole lot of benefit in recertifying. But as new versions of AutoCAD come out, you can go ahead and recertify. If you just use it a little bit here and there, it might be beneficial in that aspect of it. Okay, so I think I will stop there. You have
So
any
is
questions?
that like, I had a quick question about the certification. So is that like a class that they're offering, or is it like you go and take the exam?
They have classes. You actually go in there. They're learning offerings right here. You can go to Learning Pathways. They explore their courses. They actually have courses online at autodesk.com. It looks like you can explore courses. Click here and kind of go through here. Click on AutoCAD and search AutoCAD for design, drafting, and professional certificate certification prep. It's like a 7-hour class. You'd actually just walk through that and do your thing. You can get started at any point in time and just go straight through here, and that should give you all the information you need to know to take their certification. But again, it's $200. You've already got a job, Cody, and you're doing really well with it. Your job is a lot more copy and paste and editing than it is creating, and I know you want to get more into creating. So I mean, as you progress a little bit more and more in your job, and maybe at where you're at, you might be able to get into the 3D modeling where you're at. So I know they were talking about moving over to SolidWorks, but you could definitely use Inventor or whatever, or even Autodesk to model a lot of the stuff they actually model at your place.
Gotcha. Okay.
Okay. Brandon, got any question? All right, cool. Well, I will stop the recording.